Welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and in this video we are going to add the ability for our monster to actually attack the player to kind of finalize this game. And to do that, what we are going to do is we are going to first of all start off by creating basically a health system for our players. So we are going to open up game.h. Now in here I've got a couple of new variables. One is a font which we are going to use to render UI in our game, because obviously we want to display the actual health. And then we have got text which represents the health text that this is the actual SFML text object that we are going to render. And then we have got a player hurt timer. Now basically whenever the player is attacked, we want to display something like a red flash on the screen to indicate that the player is being attacked. So in order to do that, what we will do is that this timer will basically represent how long that screen will stay active. So when it's greater than 0, that means that the screen is going to be shown. So if I open up game.cpp, what you can see is that if I go ahead and open up my inside of my begin function constructor or whatever, we load the font from the file, and then we set our health text font to that font, and this font.ttf, you can use any font that you want, and then we set the character size to 80, or you might set it to 100, depends on what you want to do. And then we set the line thickness, which just have an outline so that it looks nice with the background and everything, which is set to 2. Then we have got an outline color set to black, and then we have got a fill color which we just set to a dark reddish kind of color. And after doing that, inside of the update function, we use our player her timer, and the way we use it is that we subtract delta time from it on each iteration of the update function. And then what we do is that we first of all get our player's health before updating anything. So we get our player health by using the player's thing, and if it's less than a 0, we just return, because that means that the player is dead and we don't want to update anything, because when the player is dead, the game will just stop. And then after that we just go ahead and if the player is not dead and the function doesn't return, we'll update the player, we'll update everything else as well. And then what we'll do is that we'll check if the player's health now after the updating is less than the health earlier, which means that the player has taken damage. If that's the case, we'll just set the hurt timer to whatever the hurt timer value is, and our weapon animation will update that and update the sound just like we were doing earlier. Alright, so in our render function, I have removed the code for the debug pathfinding rendering, by the way, and what we do here is that when we are rendering our 3D scene, what we do is we take our health text and we set its string. We basically say health colon, and we use std2 string. We get our player's health, we cast that into an int so that there are no floating point spaces shown. We just want to show a whole integer, so we convert that to an integer, we convert that to a string, and then we just put health before it, and we set our health text to be that. Then we set the origin to be 0 on the x, and that's because we want to display it on the bottom left corner. So on the x we let the origin remain at 0, but on the y we set it so that the origin is actually at the height of the text. To get local bounds, this gives us the local size of the text, and we can use height for that. And this basically makes sure that the origin is actually at the bottom of the text and not at the top like it's at default. And then we set the position to be basically 10 on the x to give it a little bit of spacing, and then window.getSize.y to make it at the bottom, and then we subtract 10 to give it also a little bit of spacing at the bottom as well. And then we draw our health text. So that works. And after this, the next thing we'll need to do is if our player health her timer is greater than 0, that means that we are supposed to display the red animation or whatever. So we create a rectangle shape which is equal to the size of our window. Then we go ahead and set its fill color to a red color, and for the alpha we basically calculate the alpha by taking our current timer of current value of her timer, dividing that by this const expression player her timer here. So we divide it by that, and then what we do is if I actually go here, after this gives us basically the percentage of the opacity that we want, and we multiply that by 255 to convert it from the 0 to 1 range to the from 0 to 255 range, which is what SFML will use. And then we just call draw to draw this shape. So yeah, that's pretty much all we need to do here. And now let's open up thing.cpp, because here we need to understand a couple of things. First of all, when creating the player, you need to make sure that we have got the health of the player specified as something positive. We are going to just specify it as 100. And then in the monster we have got a new animation definition, and you can find the images for this in the GitHub repo as always. And this is basically at index 3, and it represents the attack animation of the monster. Just contains 4 frames, and it's pretty simple. 3 frames actually. One is is just a repetition, so it's a pretty simple animation. And what we do is when we are actually updating our monster, we do a couple of checks inside of our run function. So here we first of all calculate our player distance, which we just calculate by taking our two player direction, which is not normalized, and then we can, because it's not normalized, that means we can essentially calculate the distance from it as well. We just use the Pythagorean formula, just square the x and y at them and take the square root. And if it's less than or equal to 1, which means one grid cell, then that means it's probably time for us to go ahead and display the attack. We'll get into this in a second. Otherwise we just go ahead and move the thing that we were doing earlier. So if it is less than or equal to 1, we set our thing.time to 0.5. Thing.time, as you know, is used for miscellaneous timer. In our idle and run states, we use that to represent this basically when we need to display our sound or whatever, and also we basically use it for this. But here we are going to not use it for displaying the sound or whatever, but instead we are going to use this for determining when we need to attack. So the attack frame, which is the third frame, is actually at 0.5 seconds. So we set the timer to 0.5 so that after 0.5 seconds the enemy will actually deal damage to the player. And then we set the animation of the enemy to this attack state, which is as defined as 3, and then we set the finish action to last so that it goes back to the default state running after doing this. And for the angle, we just use the 8 and 2 with the player angle, player direction, so that we are always facing the player when attacking the player. And then we just go ahead and play the monster attack sound. As you know, you can find the file for this monster attack sound in the GitHub repository. Alright, so now we have got a new state to deal with, which is the state attack. So if we are in the attacking state, what we do is we calculate the player distance again. Now you might be wondering why we actually do this again, and the main reason that we need to do this again is because because the player can, like, if for example it might happen that the monster comes close to the player and then the player goes away, and while the monster has not finished the animation of attacking. So if 0.5 seconds passed and the player is no longer near the monster, then obviously the damage should not be dealt and the player should be able to escape. So we just calculate, when we are actually dealing damage, we calculate the player distance. If the time is less than or equal to 0 and the player distance is less than or equal to 1, both of these conditions are fulfilled, then we just go ahead and deal the damage to the player. And then we the next thing we do is we just set the time to the value. We use just a random value so that we can use this for our default purpose again. So we can use this here. We just set it to a random value, and that is pretty much it. That's all we need to do. So after this we are going to go ahead and try to run this. But first of all, one important thing, well actually that doesn't matter, so we can try to run this. I basically have got all of the sprites and sounds in the asset directory. As you can find it on the GitHub repository. So anyway, you can see that if I enable this, the enemy has not seen me yet, but if I go here, the enemy will see me and start chasing me, and he'll be able to find his path around here. And by the way, I forgot to do one important thing, which is that firstly, the size of the monster is obviously way too large. This is much larger than the actual visible size of the monster. This is almost twice as large, so I'm going to actually get it back to what it was default. And then we are going to go up here when we are chasing the player, and currently the monster is a bit slow. So when we are chasing the player here, as you can see, we move our thing, and we are going to, instead of saying 2, we are going to say 3 here. If I can actually save that, I put caps lock on. Alright, so if I go ahead and run this, what you can see is that now I can go here. You can see that the monster does not see me while I am behind this wall. As soon as I go in front, the monster sees me, and he comes now through the normal path, because the size is now smaller. But you can see as the monster gets near me, he attacks me, and my health decreases, as well as the actual monster, the screen flashing and the monster being able to deal damage. And of course I can try to kill the monster, but if I just let the monster shoot, bite me, you can see that when the health is 0, the game just freezes, and of course later on we'll implement a bit of a game over screen of some sort. But as you can see, this does work, and the player is now can't do anything, the player is dead. So anyways guys, this is going to be pretty much it for this video. I'll see you in the next one, and in that video we are going to firstly do some important, just wrap stuff up as far as this series is concerned, which will include making sure that multiple monsters work correctly, and then adding a couple of miscellaneous stuff. And then we are going to finalize this series, and the next series is actually going to be a continuation of our old series about game development on Android using C++. So anyways guys, we are going to do that in the next video, so stay tuned for that. Make sure to like and subscribe so you don't miss that, and share this video with other people as well, and bye.